Okay, so welcome back. So we're looking at Wednesday night's homework of week 22. And this is using the area of a triangle. There was some confusion today, but because sometimes they use capital letter A for the angle of the included angle. That was a terrible misfortune, but typically we can use A for area, capital A for area. Oh yeah, but we can't because you see, if we're using A and B, then the included angle is C. Yeah, so we can use A for A. Yeah, well, what I was talking about here is, you see, A is then capital letter, is an angle. So we need a new symbol for area, which is a bit unfortunate, but that's just the way the cookie crumbles, because in problem solving, we really don't want to use the same variable for two different things. So we just spell it out each time. Area equals AB sine of their included angle all over 2. So let's get started here. So the first one, you draw your fraction line. You go 12 by 15 by the sine of 55 degrees all over 2. Okay? The 15, the 12, and the 55 are substituted values, and the 2 is part of the formula. Start with your fraction bar, because the numerator is quite complex. 12 by 15 times the sine of 55 degrees. Close your brackets, go downstairs, all over 2. You do need to close the brackets if you're going to have a fraction. Okay? 73. And I'm not going to bother worrying about what the particular instructions are, nor the units, except if there are no units, we'll say unit squared. So very similar problem here. And practice should make perfect. You simply multiply the 14 by the 18 by the sine of 40 over 2, and that's the area. So I'll clear 14 times 18 times sine 40. Now, I forgot to start my fraction bar, silly me. So I'm going to go all the way around. I'm going to go forward with the toggle, and I'm going to create a fraction there. And now I have a fraction bar, and I'm going to toggle back around to the end. Okay, that went very, very wrong for me, so I'll start again. And I'm learning, just as you are, that it'll cost you not to start with the fraction bar. You don't need a multiplication in front of sine, but it won't be do you any harm if you put it there either. You do need to close that bracket. You need to go downstairs with the numerical 2, not a substituted 2. Okay, call that 81. And then a square bracket is a typical symbol for area. Now here what you have to understand is that because it's an isosceles triangle, this is 10. So again, a fraction bar. The cross product of the two legs times the sine of their included angle all over 2. Okay. So 47. Okay, or even almost 40, exactly 47. So we're going to model this. Put a 9 that way. Can put 18.4 this way. x, which is common to both of them, has an angle of 82 degrees. Okay. First leg, second leg, sine of 82 degrees over 2. So above all else, we start with our fraction bar. And it's probably best to go 9 times 18.4. And it's a number, so like I said, you don't have to put in a multiplication, so I'm going to really prove that to you, that it doesn't matter that it says 0.4. You can still do sine of 82. Close your bracket. Go downstairs to your 2. Okay, and they're obviously planned to be more or less exactly, you know, to round very nicely. So close up that triangle, and it turns out there that the angle and the quantity are the same, happen to be the same thing. Okay. Now maybe this question then. So the shortcut we learned today is that we can get the angle from the inverse sine of double the area all over the cross product. So if I'm doing it, and I will give you support on that and build it up in a what's called work backwards method, but it's much slower. So we did a general analysis, and we came up with this result, that the angle is equal to the inverse sine of the double area over the product of the legs. And actually, when you want to communicate this, you often then what you want to do is you want to go back to your log tables and get the generic version from the tables. Okay, I think I might have it sitting on top here. So let's take this out. And let's drop that diagram in here. You'll want to open your log tables on the right page and drop that in here. So when we're you see the complexity here is that A, and I think because of that A, we're going to agree this. We either say angle or we say area, and let's never say A. There's too much room for confusion. So what I'm saying is that the angle after the analysis is equal to the inverse sine of double the area, and you can see now which angle am I getting. Well, you see, this is where the fun really starts. Well, I'd say we're getting this angle, okay, but it's double. And then, and if I said I'm not using any A, I'm not using an A here either. I'm getting double the area over the cross product. Okay, that might make it clear. Okay, so for this particular question, I can do, and sorry, just let me point out one other thing. This is an area and this is an area, and that makes sense because these must be of the same sort of thing. They must be like terms, otherwise it just wouldn't work. Because the thing that gets put into sine can never be like a number of meters, or it can never have units, because okay, so the inverse sine of 2 times the area over 10 by 5 root 3. Inverse sine fraction bar double times 37.5. Remember, the fraction bar is a kind of an aggregation symbol, so I don't have to close a bracket there yet. Coming down 10 by 5. Now, I don't think I can write root 3. But you see, I always want to learn. I actually might be able to, because it'll be 5 multiplied by root 3. We'll see. Then out and close the bracket, and out again, and then close the bracket. And it gave me 60, which is nice because it's that I trust that. Okay, so then I can just say that the angle equals 60 degrees. Okay, and in this context, we knew the angle was A equals 60 degrees. So I think it's a good idea to avoid using A though until the very end, because then we won't get confused between the angle and the area. And that's your homework, John. Let's just check the area answer to that question. I think it's question 8. Which were we doing last night? Is this one of them at all? 17.5. Question 8, 60 degrees. Okay. Okay, that's the end of the video.